Hey everyone, welcome to part 28 of my Pokemon game series in Unity. So in this video, we'll create a custom character animator which we will use to animate all our characters like player, NPCs, trainers and all. Special thanks to all my Patreons for making the series possible. By becoming a Patreon, you can support me in the making of the series and get access to some cool rewards like the complete project files of the series, which also contains some advanced features that are not covered here. So let's start the video. So right now we have implemented player animations using Unity's animation system, right? So if I open the animation window, okay, let me just dock it over here. All right, and if I select player, you can see that we have 8 different animations, right? We can actually try playing the animation also. And then we link all this animation together in an animator controller using blend trees, right? So the problem with this approach, that is using Unity's animation system, is that when we want to create animations for NPC, we will have to create these 8 animations separately for each one of the NPCs, right? And not only that, we'll also have to create an NPC controller and blend tree and all that for each NPC. So let's say in our game, if we have 10 NPCs, this is going to be really hard, right? So instead of using Unity's animation system, we are going to implement a custom animator with which we can animate all our characters without doing much work. Alright, so how do we implement a custom animator? So if we click on our player or NPC, it has a sprite renderer component, right? And when you play the animation, what's actually happening is the animation is changing the sprite of the sprite renderer over a period of time, right? So what we'll do is we'll create a custom script that will change the sprite over a period of time instead of depending upon Unity's animation system. So inside my scripts, I'll create a new folder called util. So inside util, I like to put things that I can reuse in multiple games. So inside this folder, I'll create a new C# script called SpriteAnimator. And let me open that up. Okay. So this is going to be a plain C# class. So let me remove the mono behavior. So inside the SpriteAnimator, first I need a reference to the sprite renderer, right? So I'll create that. And then I need a list of sprites that we should animate. Okay, so I'll name this list of sprite as frames, since it's going to be the frames of the animation. And what we'll do is we'll change the sprite of the sprite renderer to the next frame after a period of time, right? And once it reaches the last frame, we'll change it back to the first frame. So basically it'll loop. So I'll also define a variable called frame rate. So this is going to be the interval at which we need to change the sprites. Okay, so since this is a plain C# class, we need a constructor to initialize it. So let me create a constructor. So for the first parameter, I'll pass a list of sprites. For the second, I'll pass a sprite renderer. And finally for the third, I'll pass a float called frame rate. Okay, so most of the time frame rate is going to be same. It's going to be 60 frames per second. So I'll give it a default value of 0.16. So this is equal to 1 by 60 or 60 frames per second. Okay, so let's initialize these variables with the value of the parameters passed. So I'll say this dot frames equals frames. Okay, so similarly we need to initialize the other two. Okay, so next we need two more variables. One to keep track of the current frame. So I'll create an integer for that. And then we need a variable to keep track of the time, right? So I'll create a float variable called timer. And then I'll create a public function called start to start the animation. Okay, so inside start, we'll set current frame to 0, timer also to 0, and finally we'll set the sprite of the sprite renderer to the first frame. Okay, so I'll say frames of 0 to get the first frame. Okay, so next I'll create the update function. So inside the update function, we need to increment the timer. So for that, I'll say timer plus or equal to time dot delta time. Right? So every frame, we will increment the timer. And if the timer is greater than the frame rate, then we should change the current frame to the next frame. Right? So I'll say current frame equal to current frame plus 1. Okay, and what happens if the current frame is the last frame? Then we should show the first frame, right? We should loop back the animation. So for that, I'll just say current frame plus 1 mod the length of the frames. So I can get length of the frames by frames.count. Okay, so now if the current frame is the last frame, it'll go back to the first frame of the animation. So let's actually change the sprite renderer dot sprite to the current frame. Okay, and finally I'll just reset the timer. Okay, so we are done with our SpriteAnimator class. So we can use this class to animate any game object. We can animate the player, the NPC, or even the Pokemons in the battle. So to test if this is working, let's actually try and run a test animation on our NPC. So let me just open my NPC controller. So this is just going to be a test animation, and I'll remove all the changes that I make once I'm done with the testing. So to test the animation, we need a list of frames. Okay, so I'll create a list of sprites, and I'll just call it sprites. So next I'll create a reference of our SpriteAnimator class. And inside the start function, I'll initialize our SpriteAnimator. Okay, so to the constructor, we have to pass the frames. So let me just pass the sprites for that. And we need to pass a reference to the sprite renderer, right? So if you look at the NPC, you see that we have a sprite renderer. So we can just pass it by using get component. Okay. And finally, we can pass this frame rate if you want, but I just want to use the default value. Okay, and then we'll say SpriteAnimator.start just to initialize everything. And then in the update function, I'll call SpriteAnimator.handle update. Okay, so if we go to Unity, in the NPC controller script, you can see that we have sprites. So let me just drag and drop some sample sprites to test the animation. Okay, I'll use sprites 0 to 3. So let me just lock the inspector and choose sprites from 0 to 3 and drag them onto our sprites variable. Okay, so now if we play the game, the NPC should be animated using these sprites. So let's test that. Alright, so you can see that the NPC is being animated, which means our SpriteAnimator class is working correctly. So let me just remove all the changes that I made to the NPC controller class. So right now we have a class to create animations, right? So next, we also need to create a class to control different animation states. So if we open up the animator controller of our player, we have different states and parameters inside the animator controller, and it'll use this parameter to decide which animation state to play, right? So we need to implement a class that will do exactly this. Okay, so in my scripts folder, inside my character, I'll create a new class called CharacterAnimator. Okay, so let me open that up. So inside this class, we need parameters and states, right? So for the parameters, we can use the same parameter which we used in this animator controller. So we need two float variables called movex and movi and a boolean called isMoving. So let me create those. So I'll create a float property called movex, and then we need one called movi, and finally we need a boolean called isMoving. Okay, so next let's define our states. So the states here are going to be different animations, right? So we'll have animations like walk up, walk down, and all that. And to create an animation, we can use our SpriteAnimator class, right? So let me create an instance of SpriteAnimator called walk down anim. And similarly, we need a walk animation in all the other directions. Okay. So next we need the frames which we have to pass to these animations. So I'll create serialized field variables for that. So we need a list of sprites for the walk down animation. So I'll call these walk down sprites. And similarly, we need one for each of the directions. Okay, so now in our start function, first we need a reference to the sprite renderer, right? So let me create one. Okay, so next we need to initialize all these animations. So let me initialize the walk down animation first. Okay, for the frames, I'll pass walk down sprites. Oops, I misspelled walk. So let me just rename that. So for the sprites, we passed walk down sprites. And next, let's pass the sprite renderer. And that's it. I just want to use the default frame rate, so I won't pass it. Okay, so now let's initialize all the other animations. Okay, so we have initialized all the animations. So next I need a variable to store the current animation. So I'll create a variable called currentAnim. And initially I'll set it to the walk down anim. Okay, so now in our update function, we need to decide which animation to play based on the value of MoveX and MoveI, right? So inside update, I'll say if MoveX is equal to 1, which means the player is moving right, then I'll set the current anim to walk right anim. Okay, and otherwise, if MoveX equal to -1, then the character is moving left, right? So I'll set the current anim to walk left anim. So otherwise, if move y equal to 1, then I'll set the current anim to walk up. And finally, if move y equal to -1, then I'll set it to walk down anim. Okay, so we have decided which animation we should play based on the value of MoveX and MoveI. So next, I only want to play the animation if isMoving is true, right? Otherwise, I just want to show the first frame of the animation. So I'll check if isMoving is true. Then I'll call currentAnim.handleUpdate in order to play the animation, right? And otherwise, I'll just show the first frame instead. So I'll set SpriteRenderer.sprite to the first frame of the current animation. Okay, so right now the frames of the animation is not exposed in the SpriteAnimator class. So let's actually expose this using a property. Okay, so now we should be able to call currentAnim.frames, and let's just set the first frame as the sprite of the sprite renderer. Okay, so we are almost done with our CharacterAnimator class. But one more thing that we need to do is if the current animation was changed during the update, then we should actually call currentAnim.start, right? So it's inside the start function where we'll reset everything. So every time we change the current animation, we have to call currentAnim.start. But how can we check if the current animation has changed? So for that, what I'll do is at the start of the update, I'll store the current anim inside a variable called prevanim, which stands for previous animation. Okay. And once we run this, I'll check if current anim is not equal to previous anim, right? So if the current animation is not equal to previous animation, which means the current animation was changed. So in this case, we want to call currentAnim.start. Okay, so we are done with our CharacterAnimator class. So let's actually try to animate our player by using this class instead of using Unity's animation system. So back in Unity, on the player, right now we are using Unity's animator component. So let me just remove that, and instead I'll add our CharacterAnimator component. Okay, so we need to assign all these sprites. So let me just lock the inspector, and in art, let me go ahead and assign all the sprite sheets from the sprite. So walk down animation is from 0 to 3. So let me just drag and drop that to walk down sprites. Okay. And walk right is from 13 to 16. So let me drag and drop those to walk right sprites. And next walk up is from 24 Let me make this a little bigger. So walk up is from 24 to 27. I'll drag that to walk up sprites. And finally, walk left is from 35 to 38. So let me also assign those. So now we have all the sprites assigned. So let's just try testing this. Okay, so we are getting an error when we test this. So this is because our player controller is still trying to reference the old animator, right? So if I open my player controller, you can see that I'm still referencing the old animator. So here, instead of using the Unity's animator, I'm going to use our custom animator. So I'll make this an instance of our character animator class. And in here, we have to use character animator in the get component. Okay, so now we have lots of errors over here. So this is because to set the value of parameters in Unity's animator, we have to use functions like setFloat and setBool and all that, right? But in our case, the parameters are just properties. So we can actually set them directly. So instead of using setFloat, I can say animator.moveX equal to input.x. So let me change this in every place where there is an error. Okay, so we also need to replace getFloat. We just have to call the property instead of that. Okay, we have one more place over here. Alright, so our player controller is now using our custom animator instead of using Unity's animation system. So let's try and test this. Okay, so the animations are working perfectly, which means the custom animation system we just created is working fine. But there is a minor edge case that I want to fix. So if I try to walk just for a single tile, you can see sometimes the character might slide. So that's because the animation is not being played when I just make a very small movement. Let me show you again. So yeah, sometimes you can see the animation is not being played, right? Similarly, we'll have this problem in all other directions. So let's actually fix this. So the problem is inside our character animator, we are only calling the start function of the animation if an animation was changed, right? But we should also call this if the value of is moving was also changed. So let's say before this frame is moving was false, but then it was set to true, right? In that case, we need to call currentAnim.start. So that'll solve this edge case for us. So what I'll do is I'll create a Boolean variable called was previously moving, and at the end of the update function, I'll set was previously moving to is moving. Alright, so now I'll say if currentAnim is not equal to prevanim, or if is moving is not equal to was previously moving, then we should play the currentAnim.start, right? So let's test this. Okay, so animations are working correctly, and if I just try to make small movements, you can see that animations are still played for those, and it doesn't look like the player is sliding, right? Alright, so we are done with the implementation of a custom character animation system. So I'll stop the video here And in the next video, we will use this character animator to make the NPCs walk. Alright, so if you think these videos are helpful, please leave a like on the video and consider subscribing to my channel. That'll really help me a lot. So I'll see you in the next video.